So let's start. Am I audible to online? Okay. So today's meetup is SwiftUI basics and property wrapper deep dive. So let's start with it. So first of all, how many of you have done UI kit? Almost all, right? So in UI kit, it's called an imperative syntax because we are manually writing everything. So we need to tell UI kit explicitly what we wanted to display step by step in the UI part. We need to implement UI for specific target as well. For example, like iOS and iPadOS have different canvas sizes, as well as watchOS have small canvas sizes, as well as some other constraint as well. tvOS doesn't support persistence, so we need to take care of that as well, because tvOS is the largest screen size available that we can do. macOS, tvOS, visionOS, we need to create UI separately for each platform. We need to lay out manually, we need to use auto layout as well. While in SwiftUI is called declarative syntax. We just need to declare and the system will render itself for all platforms. So we only need to declare it. The UI is a function of state, which means whenever we wanted to change the UI, we need to change the state, and if the state is changed from an external event, the UI will be in sync. And SwiftUI supports multi-platform development for all Apple platform by default. So if you code for iOS, it will work for macOS as well. And we will just adjust the rendering for. We need to make some tweaks to support the other platform, but the changes will be very less compared to UI kit, and we no need to do auto layout in SwiftUI. So let's start with the today's agenda. We will see what is SwiftUI view types are, what are the SwiftUI view types are, what is property wrapper, how property wrapper behaves with SwiftUI, and we will see some SwiftUI's magic, that how that is automatic synchronization with state, and we will see the code study of property wrapper with SwiftUI auto update. So here is some basic SwiftUI code. We have a list view, we have a for each view, a text view, we have a task, and navigation title, navigation stack as well. So this is how it will look. So we can also navigate. So what are the types of the SwiftUI views? And there are lots of types. Okay, some of them we may be using it. Some of them are very less popular or less used. We are not using them all. But to learn this all, it's not an easy task at all at once. So let's categorize it. So we can categorize in 4 types. First is primitive view, the view that are very basic. Okay, for example, text, images, they are basic primitive views. Second is container views. So container view will hold another view inside the container view. A view modifier. A view modifier is a special kind of view that help us decorate the view. And some view readers like geometry readers and scroll view readers. So the list is a view. For each is also a view. Text is also a view. The task is view modifier. Okay, and the navigation title is also a view modifier. So one thing we can see that view start with the capital case and the view modifier start with dot lowercase. Sorry. Almost all code we write inside the body is some kind of view. Okay, except some extra like view store like API calls and some all. Other than that, all code is a view. Here the view means the view protocol in SwiftUI. Okay. So these are the some primitive views like text, images, colors, divider, spacer, gesture, material, and there are more. I have chosen some few. So text is this. We can see the latest, the title of the episode, the details. This picker menu is also containing text. This player UI is also a text. These are the images that we can use. Here in the tab bar, this is also image. This play button image, the menu bar image. The color is also a view, but in this case, the color is applied as a view modifier, so that it can the colorize the material, the element. The divider is a thin line. We can use outside of the list as well, but it is a very thin line. It will adjust according to the parent layout. If it is V stack, it will be horizontal. If it is S stack, it will be vertical. These are the spacers. Spacer are empty white spaces. Okay, so whatever the available space is, it will take all. The gestures, so that we can perform some actions. So for example, in this we can toggle to play. And the material is a special kind of view that will blur whatever the content is below it. Now let's change the topic and see a never. Never is a Swift type that doesn't have a value, or it cannot be constructed. Okay, this is a part of Swift language. So this is how it is defined inside the language itself. So it is an empty enum. So an empty enum doesn't have any case, so it cannot be constructed. It cannot be initialized. The function that returns never. So for example, we have a forever function which is having an infinite loop while true. Okay, so this function, whenever we enter this function, we will never return. Okay. Another example is the crash and burn function, which is calling fatal error. So at this point, the program will be terminated, so there is nothing to run, so it will never return from this call. And another one example is that result type. So result is a Swift type that takes two arguments, generic argument. First is a value, second is error. In this, the error is defined as never, so it will never return an error. So in this case, we do not need to write the failure case because it will never throw an error. A function with a never return type is called non-returning function. The closure, method, computed property and subscript can also be non-returning, and we will see how SwiftUI uses this inside their primitive views. So as if we go inside the Xcode and jump to definition for text, we will see that its body is declared as never. That means that this body will never execute. Same for the image and same for the color, spacer and other gestures as well. So why this all views body is declared as never? Because it will never execute. Then how the SwiftUI will show the image or text. So if we see the view protocol, we will also find that it is referring to a type alias body, which is also conforming to view. So this is a type kind of recursion. So the view is the view's body should be view and its view should be body should be view. So when it will end. So this is called recursion in protocol conformance. Okay. So when we see the SwiftUI documentation, we also see that never is also conforming to view. That's why that is how the SwiftUI can declare its body to never, because never is also a view. So to satisfy that view protocol, right? So body is never. So whenever SwiftUI sees a never type, it knows that it needs to use the other technologies to render on-screen UI. The other technologies are the same: the core animation, core graphics, core text, UI kit, app kit, etc. Okay. So the SwiftUI defines that in this context, if I see the never, I need to use that core text to display the image text, and core animation to display the image and all animations as well. So one example we can see that we have UI representable, UI view representable, and UI view controller representable. So this is the example that is confirming that the SwiftUI can also use other technologies to render. So here we have the UI view representable, which is also a never body type. So in this protocol, we have one function requirement that should make a UI view, and it should be a UI view type. And UI view type is nothing but the UI view subclass. Okay, so it should be the subclass of UI view. So here is an example of that, because this is an audio route picker. So when we tap it, it will show the audio route where to play the audio on device or on Bluetooth device or on Apple TV, etc. So this is how we can conform to UI view representable, and we can return the AV route picker. Okay, so AV route picker is from the AV Foundation, AV framework, and this is how it will look. So when we click on it, it will show this kind of AirPlay picker. So this is using the UI kit as a in behind. So let's come back to the primitive view, like view types, and then let's see what is the container view. So these are the container views. There are a lot more, but I have chosen this because my UI uses this. Okay, so basic edge stack. Edge stack is a horizontal stack. So to create it, we need to provide the different views to lay out horizontally. So this is an edge stack, and in this stack, these are the views that are laid out horizontally. Okay, and this is the code. Here we have the edge stack, and we are defining like the player image view, which is this artwork, and we have this view modifier called frame. So I can limit the size in this small toolbar. Then we have the player info view, which is the middle one, the title and the duration of that episode. And another one is the spacer. In case of that, this is a small title, it will only show in the leading side. And then we have the button, which will be this button for the play pause control. Okay, and this button has a different initializer that taking the another view inside this. So button is a container view that will take another view to draw its content, and the label is called argument is called label. Okay, and then we can disable it if we don't have the current ongoing session. Another one is the VStack. So VStack is the content we are showing in the player info view. Okay, so the content will be shown vertically. So here is the content. Here I have that a conditional content. If the session is available, then we can show the session display title and other information like elapsed level. And if we don't have, then we can have the normal not playing text. Okay, and this will be shown vertically using the VStack. We have this jet stack. So jet stack is a kind of view that will overlay. So in the Z axis, so we can see that the yellow circle, yellow highlight is the image view, and the play button is on top of it inside the Z axis. So we can display like this, code like this. So we have the library image view, we have the hide fix, and we have the play button. So they are next to next. We don't need to so JetStack will display this one first and then overlay it with the play button. So sequence will matter, like what is the depth effect, depth layer for the each layer. Then we have the lazy edge stack. So this is similar to edge stack, but when the content is larger and we are showing inside a scroll view, then it should optimize for memory, runtime memory. So the lazy will be only occupy the memory which are the most visible items in the screen. So this is how we can define a lazy edge stack. And we have the dynamic item. So we are using for each view, which is also a container view, and we are providing the item and we are providing a stable ID so that it can identify like which to allocate and which to deallocate. Similar to index path that we are using in collection view, table view. Okay, and we have the V stack to display that image view and the info view inside the lazy stack. So this is stack, so it will be flowing horizontally, similar to those at the bottom as well. Then we have the scroll view, because this is a complex view, because it also has a horizontally scrolling cells. So I have used this as a scroll view, and this is the scroll view code in which we are also using the same for each view, the cells. So cell is a section like continue listening, new episode and recently added. So there are 3 cells in this. So we are looping over them and we are making a section and providing a section header with the text and some view modifiers. Yes, for each view is also a view. That means this is conforming to view protocol. Okay, and as we have seen before, that is the for each view that takes some item and the ID, and then we can iterate over it and we will get the single element, and we can use that information to display. Then we have the tab view. Okay, so tab view is the simple tab view, but I have a dynamic tab, so I'm also using for each here. So this is kind of for each repetition. Yeah, but tab view also take a selection. So we can get the current selected tab from the store, and we can have the tabs, which is also dynamic. So we are using for each. So whatever the number of the tabs, it will be showing there, and we using the special view tabs view. This is a custom view. So for the each element, each item in the tab will be displaying here. And to display these icons, we are using a tab item modifier, which is also taking a view inside. So this label has 2 components, a title and the image. Okay, then the navigation stack. It is a bit complex because it is like managing the navigation layer. So, but the syntax is very same. We have the navigation stack and taking a binding for the path, and the first one is the root view. The first closure accept as a root view. So this will be displayed as a root view, and for the other destination, we will have the destination view. Okay, so whenever this path changes, it will invoke this closure and this view will be presented or navigated. The label and text are different. Text only display this text string value text, but label also takes an image. Okay, so this is the one initializer that takes a title and the system image. We can also provide custom images here as well, and this is the another initializer that we can provide a raw text and the image as well. Then button. This is also a container which is taking another view inside. For the simplest view, they also accept a string type for the title, as we see in the label, and we can also have any type of view inside the label. So this is for this. We only need to show the icon, so we are using that one. And this is the menu. Menu is also a container which is taking button or label. Okay, so inside the menu we wanted to display anything, buttons, multiple buttons. So here is this button, and if we click on it, we will show options like this, a picker, a menu picker like this. Okay, now comes to the view modifier. So this is the official definition of a view modifier. A modifier that you apply to a view or another modifier produce a different version of the original value. This is a complex one, so let's forget about this and let's understand our way. So we also can classify view modifiers with this. One is for the decoration. So we have this V stack in which we have the image and text. So we can apply the padding, we can apply the background color, we can apply the clipping shape for that background. So this is decorating the view. like background and clipping shape. So this is the these modifiers are of decoration type. Another view modifier are to pass values in environment or preferences. So for example, here I have a list view in which I wanted to select multiple items. So I have the selection for set. Okay, so this can contain multiple items. And here in the list selection, I have passed the binding for the selection set. Okay, and inside that I am just looping over the 10 values. And if I run this code, I can see this, but there is no selection. So I can modify the environment with this active constant for edit mode, and this is how the UI will be affected. So this is an environmental view modifier. This is there is also a preference modifier. So we can like environment is from parent to child, and preference is from child to parent communication. Okay, so in this we are saying the list that we wanted to have a selection mode active, editing mode active. And this is the reading dimension or like geometry reader. So this view modifier will give us the dimension, the position, height, width, etc. for the targeted view. Okay, so here I am using a background. So background view modifier will be the same size of the parent. Okay, and inside that I am using a geometry reader with that will give me a proxy value. Okay, and I am using clear color so that the UI display of the UI, look of the UI doesn't change, and we are applying another modifier for on change of proxy.size, and we are also passing the initial value so that we will get the notification from the start. And we have these two values, old value and new value, and we are just assigning size to the new value. So we will take the latest one. And another one is the proxy.frame in global coordinate system. Okay, so this will give us the size, position inside the global coordinate, and we are assigning that to position to the new values origin. So this is how it will behave. Okay, so I have used a scroll view or list view. Inside that the image and the title is in the V stack and have some padding and background. So I am listing the position and size here. So if I play again, you can see that it is updating as it is moving. So the position inside the global coordinate is changing when it scrolls. So we will get this information from this. And this is the whole code if you wanted to look at. So these are the view modifiers. Last one is the observing life cycle modifiers, like on appear, disappear, and on task. So this will give us the information whenever the view will be appearing and disappearing. And the task is the special one because the task allows us to call an asynchronous API call in this. So whenever on appear calls, the task will create a capital task type, and when it is on disappear, it will cancel it if it is already running. One more time, the view start with the capital case and view modifier start with dot lowercase. So these are the now let's go to the view readers, which is we already seen that geometry reader. Another one is scroll view reader. Okay, so the scroll view reader also give us a scroll view proxy, and we have this proxy scroll to element 40. So if I click on it, it will scroll to 40. But if you see, if I click again, it doesn't scrolling, and if I click again, it will scroll. So without any anchor point, this will only scroll if the item is not inside the visible area. Okay, and if you provide the anchor, there are other version of this as well. So this will always try to scroll at the top anchor. So these are the view types. Now start with the property wrapper. ऑनलाइन में सब है ना. So start with the basic syntax. So this is the property wrapper, and we start with this. We will get this error, and to fix it, we need to write a wrapped value, get computed stored property wrapped value, and we can also make it any generic type. We can name anything in generic. But why we need view property wrapper? So we have this view model class that we are calling for displaying the post, and we have these two properties, page limit and page offset. What if we wanted to store those values in a user default? So we can write like this. We will have the getter and setter for this value. Inside the getter, we are returning the value from the user default, and inside the setter, we are setting the new value for the same key. So you will see that these are the common code which is repeated. So we can copy this code and create another structure and just write it like this with the same. And we apply the @property wrapper attribute, then it will ask us to change the value to the property name to wrapped value. In this, we can generalize this with the key argument, and we can also ask for the default value, and we also generalize the type to generic type T, and then we can write like this. So this is very less code. It will be synchronized to user default whenever we access or write it. But how if I wanted to write like this, which is similar to what we have in the app storage type, we will get this error in extra argument wrapped value. This is happening because the default initializer is like this. The first argument is key and the another argument is default value. If we add another initializer, that will first take the wrapped value and second is the key. The first wrapped value will be considered as a default value. So we can have this syntax here as well, and we can also change it to this. You will see that I have written this observation ignored at macro here. This is because if I remove this, I will get this error, and this is because the macro doesn't play well with the property wrapper yet. So we need to write like this for this case, and you will see that this property wrapper is written inside the view model. Okay, but what will happen if we write inside a view? It will work. We will see the label and cell. But if we wanted to update it, like inside a button, if I wanted to increment, we will get this error. And to solve this error, we need to make this non-mutating. So you will see that our definition of the user default is a structure, and structure is by default immutable. If we wanted to mutate something, then we need to mark it mutable, mutating function or mutating var. But in this case, we are only updating the user default. Okay, so other are constant. The other properties of this structure are constant. So we are not changing anything. So we can annotate this setter as a non-mutating. That means we are not changing any properties of this structure. We are changing an external property or external object. And by doing this, we will not get this error anymore. And this is how it will look. But if I click the increment button, it is not changing. Why it is that? So a page limit is not updating when it's increment. In other words, we can say that the SwiftUI doesn't observe the value changes, or we can say that it doesn't observe the state changes. Then there is the another part of the SwiftUI, which is called attribute graph. This is a private framework, and if we have code anything in SwiftUI, we will somehow see that attribute graph cycle detected through attribute 219. So this is happening when we are not updating, like we are updating the value whenever the view is in rendering mode or not updated. And you will find this, if you have Xcode installed, you will find this at this location, the system library and the private frameworks and attribute graph.framework. So what does the attribute graph do? So it reads the values declaration and it creates a view tree, okay, from that declaration, and then it keeps a track of the state binding and other view dependencies, and it creates a persistent render tree up from that and observe the state changes and then recreate the view tree and throw away the existing tree and recreate the new tree and then re-render the render tree with the smart difference. So it doesn't need to re-render everything, it will only re-render what is changed. So this is the views declaration. So we have the code like this, right? And we are marking this body as a sum view. This is an opaque type. An opaque type is that the type information is not directly visible to the user or developer, but the compiler knows the whole information about this. How we can say that if we write this function that will mirror the whatever the like this will emit the type information of that view. So if we print this, if we attach this function to a view and we print this, we will get this code. And using this code, it will generate a view tree. Okay, I have highlighted some of the views with purple color. So that views we know and we use every day, and the other things are grayed out with some underscore. These are the internal views that SwiftUI uses to identify what is the view hierarchy, and using this it creates a view tree like this. So let's go back to the code and see that we have this state property is loading and we are using inside a body. So it will register that property to the conditional content, and whenever that property changes, it invalidates the view tree behind these conditional content, and it will re-render the body, recall the body. It will scan it, read it. It will then recreate the view tree, and the render tree will be created like this. We will see the indicator. Whenever the value changes to true, false again, true again. I think I made mistake. Then it will create the new render tree with this. Okay, so this is how attribute graph will do the work, the SwiftUI magic in the behind the curtains. And to know more about this, here is a very good talk from the Chris Adolf, A Day in the Life of SwiftUI View. You can look more into this. I wanted to mention this, how this state binding and other dependencies are keeping track, like how attribute graph will keep track of these dependencies. So let's see the definition of the state property wrapper. We will see a special protocol conformance called dynamic property. If we see for the binding as well, we will also see that dynamic property conformance at the bottom. And same for the environment. So if we see again, look for the definition for the dynamic property, we will see that this is the dynamic property definition, and it only has this function, mutating function update. Okay, but if we look into these comments, documentation comment, the interface of stored property that updates an external property of a view. Okay, external property. Another one is that the view gives value to those property prior recomputing the body of view's body property. So whenever the view's body is recalled, it will give the value to the property wrapper, the updated value. Let's see how this is happening. So we have this code, and the Swift will read this code and create this view tree. There is a special storage, external storage from the attribute graph. Okay, we have the whole code definition here, and it sees that state property wrapper conforms to dynamic property protocol, so it will allocate a storage in the attribute graph storage, and that allocation is linked to the attribute graph tree. Okay, so whenever we are changing on the task, we are first changing is loading to true. Okay, so this change will affected this property, and since this is a state property wrapper, it will notify the attribute graph that this value is changed from false to true, and it will notify the view tree, and then it invalidate the tree behind it, and then it will recompute the body and update it again. And after some time, when the loading is false, it will also be notified to attribute graph storage, and then the value will be changed again. It will again invalidate the view body, and again the body function is called, body method is called, and this is how the SwiftUI magic is happening behind the scene. So let's study next code for the demo. So I'm creating a new project. Am I sharing? Okay. Let's wait for the SwiftUI preview, Xcode preview to load. Okay, we have the preview ready. Okay, so let's start with the property wrapper definition. So I'm creating a new file called storage, and let's declare the structure storage, and I'm annotating with the property wrapper. So it will ask me to write the wrapped value, so I can fix it. I need to provide some value, so I am generalizing this to general T. Okay, in this I need to give the getter and setter, and we will have the user default. We need the key, so we will ask as an argument. We pass and we typecast as a T, and if we don't have, we can ask for the default value, and this is also the same type. Okay, in the setter we will also have the set value for key. We will have the new value and we use the same key, and this is our storage property wrapper. Okay, so let me write a view model. I'm declaring a class. Okay, and I'm iOS 17 right now, so I can mark this observable. Okay, and I will have a function to fetch post. So, and this function will be an asynchronous, and it can also throw, and I will have the array of post, and I don't have the post type, so I will just construct it, and this should be codable because we will be decoding from the internet. And so let me create a URL for the URL. I forgot the URL, so I will just Google it. and if we go to the posts, we will have the post. So I will use this URL here, and we will have the data and the response from the URL session.share.data from URL, and we will pass this URL, and we will decode the posts from JSON decoder, array of posts dot self from data. Okay, and I need to make this a tuple, and we are not using response, so I can underscore it, and we can assign this to like directly self.posts. Okay, and then I can use this post view model, and I can display this list for each store.post. ID is self, and or maybe I can just write title because I only have the title, and we can just display the title. And inside the onAppear view modifier, we can call the fetch post, but this is an asynchronous call, so I better use task. So I can just write try await store.fetch post, but task is only considering await, but it doesn't handle error automatically, so we will catch it with do try catch, and for now we are just printing the error. Okay, and title. Okay, let's just make it self, and oh sorry, this is the post, and we have the post.title. So you can see that we are fetching from the internet. Okay, so this is the basic SwiftUI, and now let's use the property wrapper here. So at the storage, I can have the key for the page limit, and I will have the default value 10 and page limit. Okay, and I need to provide a type. So this is building. Yes, and this is the error because of that observable macro, so we will ignore this observation, ignore, and we have the successful compilation. Okay, but if I wanted to like use it, so I can simply print the page limit, and if I open this and go to the view, you will see the 10 printed out. Okay, and if we change after this, so the page limit plus equal to 1, then I can also print again. So you can see the 11 is printed now. Okay, so property wrapper is working. If I just run it on the simulator to show that it is persistent, we can see in the simulator. Okay, so the first 10 and 11 is printed. Let me just make it like this. Okay, and if I run again, it will be 11 and 12. So the 11 and 12. So this means that our property wrapper is working. So how about we use it inside a view? So I can use this. Okay, let me just go with this. So what about if we write like this? We don't write default value here, and we write like this. So we will get this extra argument wrapped value error. So to fix this, we need to change the initializer init with. So this is the default initializer, and we can write another initializer, with the wrapped value as a first argument, type same key, and key is the second one, and we can just write default value as a wrapped value and the key as a key. Okay, and now this error should be gone. Okay, so I can copy this and just paste inside the view, and to display this I am using the toolbar, another view modifier that will display inside. So in the toolbar we have this toolbar item. It will only take this toolbar item as an argument, and we can place it on the top bar leading, so on the left side of top, and we can just simply text this the page limit, and we can use the page limit here. Okay, and I can resume my preview, but it's not showing because the toolbar in the top side is a part of the navigation view controller, so I need to wrap this inside a navigation stack. Okay, and you can see that I am also incrementing on the task modifier, so you can see that value is 14 now. Okay, so for other tasks I will for now not change anything from here. I will wanted to change from the UI part. Okay, and I'm not needing this, so I can get the more space. And so I'm adding another toolbar with the top trailing, and I wanted to increment it by this. So I just increment and page limit plus equal to 1. And you will see this error. This is complex error because the Swift language itself cannot get it right. So this is happening because we have not make it as a new non-mutating. So if we make it non-mutating, okay, sometimes autocomplete doesn't work, so we can simply write it by force and it will get it no. And now it's accepting, so we are building fine. And but if you wanted to increment it, the view doesn't reflecting. Yes, because the attribute graph doesn't know about this. If I change this from a state property wrapper, var another or offset integer starting from 0, okay, and I change this to offset, and if I change from here to offset, okay, and in this case the offset, whenever I click increment, offset is changing. In this case, because the state property wrapper conforms to dynamic property, the attribute graph will know that this is a dependency for this view, so it will store that inside the storage, external storage. Okay, and whenever it changes, SwiftUI will know that the value changed, so we need to recompute the view tree. So if I can let me go by this again. So if I run this inside the simulator now, and I put a breakpoint inside the body, okay, and yes, you can see that this is not displaying because we have added the navigation inside the preview, but the entry point only have this, so we will also have the navigation stack. Okay, and now I run this inside the simulator. So first time we wanted to display anything, so it will read the view, so we will get this breakpoint. For now I'm closing this. Okay, so this is the our normal list view. Okay, and if I scroll this, it doesn't calling this body again, but if I click the increment, we will see that this is being called. Okay, so the attribute graph is knowing that the value is changed, so it need to recompute the body. So, and it will get this latest value from this. Okay, so offset is 1 now. But in our case, the page limit and our storage property wrapper. This is not observing because we didn't tell that we wanted to manage external storage for this property wrapper. So let me change this back again. So I get the page limit and I will update the page limit. Okay, so how can my property wrapper notify attribute graph or the to that, so that my value is also should be maintained or observed? And currently we are storing inside a user default, which is a separate entity. Okay, so how this SwiftUI will know that? So we can start with simple. We just mark it as a state private var changed, and I am considering as a boolean initial value false. So whenever I am changing the value, I just trigger that the value is changed. Okay, and the state is unknown attribute because it is from the SwiftUI. So I need to import SwiftUI. Okay, so whenever I change the value, I will also say that the property is changed, so I will toggle it. Okay, but doing this is not enough, and let's see. So we have the page limit of 12, and if I increment it, not updating, and let's see if we have the breakpoint as well. So I make the breakpoint again, and if I increment it, it is not being called. So this is not enough, because only writing is not enough. We also need to read it. To read it, I just use this changed. Okay, and now okay, I need to return it, okay, because it's multi-line execution. Now the first time the breakpoint is called. Okay, and now I try to increment, not working, because we are using the state as well here, but we are not making this dynamic property protocol conformance. So whenever the attribute graph reads our code, it will check for the dynamic property protocol. If it is conforming to that, then it will register it. Okay, and now if I run again, so this is the breakpoint for the API call, and if I run again, I click, then my body is called again, called now, so that attribute graph will know that now we are changing some value, so we need to recall the body. And you can, if I disable this and if I click again, you can see that it's increment. Okay, but I also wanted to decrement, so that will give me a chance to optimize my code again. So I am just using a stepper. So stepper is a view that will allow me, that will give me two buttons for decrement and increment. Okay, so I'm just I'm giving an empty title, or I can just say the page limit, and I now need a binding. Okay, so for the state we can write the $sign dot offset, but in this case we need to write like page limit, but cannot find $sign page limit. This is happening because in this our property wrapper we didn't provide the projected value. So if we write the projected value, and this can be anything, so for now we wanted a binding for T, and we can initialize the binding with just this. So we need to return it, so we will return self.wrapped value, and whenever we have the new value, we will set it new value. Okay, as I write this code, my code is now compiling, and I can now run this, and I can also increment and decrement. Okay, how about like we don't use the @state? How we can notify our attribute graph that we wanted some observation, right? What if we don't write like this, and still we wanted to notify that we are like we have some dynamic value? So we can utilize the combine framework as well. So I'm importing combine. Okay, and I'm creating a private class inside the storage property wrapper itself called internal storage. Okay, and inside this we will have the same thing like this. Okay, so I will write two functions, the one the get value or just value that will return a type T. Okay, and I can use this same. Okay, so I need the key here as well and the default value. Okay, so hence this is class, we need to provide a special initializer, so we'll have that, and whenever we wanted to change I can write a set value and have the new value inside with the same type, and I can just write the user default set value for key, new value for key. This is type T. Okay, and type T. So inside this I need to use that storage internal and inside this initializer. So for this I am removing this for this demo purpose, and I am just initializing the key and the default value. Okay, and I need to mark. Okay, it is, and inside the wrapped value we will use that internal storage with the value, and we will set internal storage set value new value. Okay, and if I change this, it will still again not work because we haven't told attribute graph that it is dynamic property. So for this I can make this an observable object protocol. Okay, in this we have requirement of object will change property, is computed property, so we will have this, so object will change. Okay, and I just initialize with the empty value, and whenever we are changing it, we will mark this object will change dot send. So whenever the value is set, we will also update send the event to object will change. And if I run this, still not enough, it's not working. Okay, to make it work I also need to use the observed object here. Because observed object is also a property wrapper and is also conforming to dynamic property. Now this will work. So I can decrement and increment. Okay. How about we also don't want to use combine? Then we can mark this as observable. From the iOS 17 we have the observable macro, so we mark this as observable, but whenever the value is changing, the local property is not changing, so we can utilize the same private var changed boolean, and we can just update. Okay, and if we don't need to mark this, and not working because we also need to read it, so I can just read like this. Okay, so this is how the magic of SwiftUI is happening, and the responsible person is proper attribute graph. Okay, and thank you. Any questions also from the online persons?
Hello, Ratna Vivek this side. Can you explain a little bit about the navigation stack and navigation view?
Yes, so navigation stack come from the iOS 16 or 17, which is the advanced version or like improved version of navigation view, and navigation view is deprecated. So you can see my screen, right?
Yes, Ratna.
Yes, so I create a new view called home view. Okay, and I import the SwiftUI, and we'll start with the view. So I can just write view and it will auto complete me the whole thing. Okay, and I can wrap it inside a navigation view. But you see that navigation view will be deprecated in future version of iOS and use navigation stack or navigation split view. Okay, so we'll look for the navigation stack. So navigation stack is very simple. We can just have the list view here for the purpose, and we can have the 1 to 10 ID self and dash text $0. Okay, and if I resume the preview, you will see that it's working. But if I make this a navigation, if I wanted to navigate, I can just provide the value or the destination view itself. So I can say that my destination view is detail view for this $0, the whatever I am getting this, and just make the label to this text. Okay, so okay, destination view 1. Okay, so navigation stack doesn't understand the $0, so I will just make this item inside this, and I will just pass as an item and item, use it as an item. Okay, now it's navigating to me the detail 1. So this is similar to what we have navigation controller dot push view controller in UI kit. Okay, but if I wanted to have a programmatic control for navigation, then there is another initializer that takes a path. Okay, and we can define a path. Okay, this can be anything. For now I am just creating an enum for the destination or path destination that I wanted to go to the item detail, and I just wanted like integer for now. So okay, and I can have this path destination as an array. Initially we don't have anything, so we create an empty array and we just write the $path. Okay, and as we provide the path, we will have the destination. Let me just recreate this so I can show you that navigation stack, path and route. Okay, so this is the binding required, so we'll use the $path, and we just have that list view that we had earlier. That item inside this, and we will have this text item. Okay, and this is the error, no exact matches. This is calling because it needs to be hashable. Okay, so if you go inside this definition, and you will see that data should be hashable. Okay, so that is why it was giving an error. So you can see that we have the list, but how we will navigate. So I am wrapping this inside a button. Okay, and then I can just path dot append element, and I can just add the item inside. Okay, so as I wrap this inside a button, it changed to that primary color, and you can see that now I don't have the destination view. Okay, so what I can do is like I can write that navigation destination for, and the type is like my path destination dot self, and I will get the destination here. Okay, and I can switch that destination because this path destination is enum. Okay, so destination, and I can get the let item, and I can have that vstack here, image, okay. So if I click this, still not working because navigation destination should be inside the navigation stack. So you can see that I have gear. Let me make it, I can provide a font to large titles, so you can see that. So this is how you can programmatically control the navigation.
There is one more concept called navigation manager.
Yes.
Can you elaborate a little bit about that also?
Sorry, I didn't get the last part. Can you repeat, please?
Can you elaborate a little bit about the navigation manager also?
Navigation?
Manager.
Navigation manager. I am still not getting.
There is a concept to create a navigation manager to navigate the pages, view in the SwiftUI.
Okay, so you want the single manager to control all application navigation, right?
Yeah, like that.
Yes. So from this you can like make it external. Okay, and you can have another details, so like some details like settings. Okay, and to make this a manager, you can also extend this path destination to environment keys. Okay, so in this we wanted to have the default value, and then we will initialize initialize this with the path destination as an array, and we will have the empty value. And we can extend this environment values okay, and we can have that navigation manager or something, and we will have that path destination array. Okay, and inside this we need to provide the getter and setter, and the getter is very simple, that path destination dot self, and self is path destination dot self is equal to new value. Okay, so now I can have the environment here, and I can use that navigation manager. Okay, and I just make the manager to append the items, and I need to make the manager here. Okay, you cannot use like this, so let have the initial value of this path as a path destination with the empty value, then use that $sign path inside. Okay, and inside this we can have the environment override for our navigation manager, and we can write the value path here. Okay, and let's also make this separate view. So I will make this as a view with the item view, and we'll take as item as an integer, and we'll have the button, and inside this I can use the environment navigation manager, then I can append it. Yes, this is we need to make some tweaks to make this workable. So navigation manager is an array, and we have that append, because this property wrapper, environment property wrapper, we have set it as a set, but it doesn't mutate directly. Okay, so we can have like the manager type is an array. Okay, but we cannot mutate this array, so we'll need to manage something like else, like dismiss. So dismiss provide a dismiss action, right? So dismiss action, like, so in this we need to make this dismiss as a call. Okay, so if we look inside this dismiss, it's a dismiss action, and dismiss action is a structure, and it is marked as a call as a function. So we need to use another trick, and we can have a structure that will have like navigate or like path navigate, that have and we need to access this here as well. This is a bit complicated, but we need some trick here to access it inside the environment. Or like I can have a class make it mutating, and inside this class we like for the default value we can have the navigation, and we just initialize it empty value, and to assign it we need to have the navigation. What is the name? Path navigation here, and we can initialize this, or like we can have paths initialize this here, and just okay, 9. We will need this as an empty array, or okay, path. For this one we'll need path, but we don't have the $sign because we need to make this bindable, and it should be observable. So you can see that it's getting very complicated right now, and we don't need to return this because now we have this value. Okay, and we will make this variable, and then we have that destination must be case for the settings, and we will have the settings view. And inside this, now if I can make append maybe item in item, hope for if it is work. Okay, we have nothing to display here, item or like item view with the item, and you can see this is working. So you can use this as an environment.
Thank you, Ratna.
Yeah, thank you for asking. Yeah, any other questions from other members from online community? Yeah, thank you for joining.
Thank you so much, guys.
Thank you, Ratna.
Thank you, Ratnesh.
Thank you, Ratnesh. It was very great presentation from your side. Thanks for having us. Thank you.
Thank you.
Thank you so much, guys, for joining this amazing event, and thank you so much, Ratnesh, for taking this